Alright guys, moving on to 4.2, we got our warm-up here. In 4.2, we're going to be kind of getting into triangles, and when we talk about triangles, we're going to be going over, obviously, classifying them by their angles and their sides. So that's what you'll kind of see in the warm-up here. We're talking about angles and sides and things that we should know at this point. So go ahead and pause the video, do the warm-up, and we'll go over it. Alright, so 1 through 3, again, what we're doing is we're classifying each angle as acute, obtuse, or right. So again, you need to make sure you know what that means. Again, acute means less than 90 degrees. Obtuse, that's an ugly that's an ugly arrow. Okay, obtuse means greater than 90 degrees, and right means equal to 90 degrees. Again, those are things you need to know in this chapter as we start classifying triangles. So in this one we have a right angle, so this is a right angle. It's 90 degrees. 2, that's less than 40, so this would be acute. And number 3 is greater than 90, so that's going to be obtuse. Easy if you know the definitions. Number 4, if the perimeter is 47, what we're going to do is find x and the lengths of the 3 sides. So for this guy, I'm going to go ahead and move it up here, so I got some room. Again, perimeter, you got to understand what that means. Now, perimeter is going to be the sum of all your sides. So, you know, if you add all your sides up, you're going to get 47. So that's exactly what you do, is you set this up as a sum of your 3 sides. So 2x plus, not 7, 6. So 2x plus 6 plus x plus 3 plus 3x plus 8. That's going to equal 47. So here we're just going to combine our like terms. I got 2x, x, and 3x. That's going to be 6x. I have 6, and then 8, 9, 10, 11. 11 plus 6 is 17 equals 47. So now I'm just going to solve this for x to get started. So subtract 17 from both sides. Therefore, 6x equals 30. And then divide both sides by 6. And we get 5 for x. Now it did say find x and the lengths of all 3 sides. So you would kind of, let's just, so we can keep track of what we're doing here, I'm going to call that A, that B, and that C. Those are my 3 vertices of my triangle. That's where the angles are formed. So I'm going to find AB first. Now, we haven't had to hit this a ton for a while. Mostly in chapter 1 we were hitting this, but understand I'm finding a length. So don't put AB with a line on top, because we're trying to find the length of the segment, not the segment. So AB equals, we're going to just write it that way. So it's going to be 2 times 5 plus 6. So that's 10 plus 6. So AB is 16 units, whatever that is. I don't know if it's like inches or feet or whatnot. BC, that's going to be x plus 3. So 5 plus 3, which is 8 units. And then we have AC. AC is going to be 3x, so 3 times 5 plus 8. So 15 plus 8, or 23 units. So that's your warm-up. Again, those are going to be using, you know, skills that we're going to be needing for 4.2. Alright, so moving into this lesson. So the goals for today, tonight, this afternoon, whenever you're watching this, students, for you guys, are going to be able to classify triangles by their angle measures and their side lengths. So you can kind of get that idea from maybe the warm-up, because we were talking about angles and finding side lengths. So we're going to do that in triangles. We have to understand a few new definitions. And students will be able to use triangle classification to find angle measures and side lengths. So in other words, we need to know the definitions and then apply those definitions. Alright, next up, Classifying triangles, we need to kind of know the different parts. We have if I was looking at my triangle here, AB, BC, and AC are the sides. So when I'm talking about like the entire length of between 2 points here, that segment, that represents a side of that triangle. And then the points, A, B, and C, are the triangle's vertices. So if you don't know that already, I mean, at some point you should have seen that. But we got sides and we got vertices. Those are two key words that you need to make sure you understand as we move through this unit. So, obviously, one of our goals here is to be able to classify triangles. So you need to know what makes a triangle a triangle. Like what, there's different types, and you need to know, again, what makes an acute, in this case, an acute triangle. An acute triangle. So some things you need to know, obviously, coming in. I talked about it in the warm-up. And if you don't know it, you need to write it down now, is what the words acute, I'm just going to kind of put these words down so you know them. What does acute, obtuse, and right mean? Again, I'm just putting it up here, I'm not writing it down unless you need it. Acute means, again, less than 90. Obtuse means greater than 90. And right means equal to 90. Because we're going to classify our triangles that way, based off of these words. And if you don't know what these words mean, you should probably write that down. So you got your acute triangle, and an acute triangle has 3 acute angles. So all these angles, it doesn't have to be a very particular angle. It just has to be less than 90. They all have to be less than 90. If one is greater than 90, it's not acute. So it has 3 acute angles. An equal angular triangle, these are all classifications by angles. You may want to put these in a chart here. So you have your acute, your equal, I can't spell, equiangular, and obtuse. You're going to make a little chart here, and these are, triangles by angles. So when you're putting them all together, you can make like a little chart and kind of write the information in that chart. I'm not going to write it down because I already have it here, but again, you can make like a little chart in your notes. Now, the one thing you want to do when you're talking about an equal angular triangle is, the angles are all congruent. They are congruent, but you know what? When you're solving a problem, the fact that they're congruent is not going to help you. You're going to need to know what the heck that angle is. So if you think about it, let's think of 3 angles that if you added them up, you'd get 180. That's something you need to know about a triangle. It's not really tested yet, but it's still something I feel like you should have learned in the past. So I'm just going to go over it now anyway. And that is that the 3 angles of any triangle are going to add up to 180. So again, you don't have to know this yet. There is a theorem associated with it. We'll go over it when we get to it. But the sum of the angles of any triangle equals 180 degrees. So if you know that, then you want to think to yourself, x plus x plus x equals 180. If I'm dealing with an equal angular triangle and say these 3 angles are all x, then what is that angle? So this would be 3x equals 180. So find out. So x plus x equals 180. 3x is 180. Divide by 3. And x is 60. So here's what you really need to know when you're dealing with an equal angular triangle. The angles are 60. Yeah, they're congruent, because if you have equal measures, that means they're congruent, but they're 60. Okay, and our last one, actually it's not our last one, sorry, we have one more. But you have your right triangle. This one's pretty simple. It's got 1 right angle. You cannot have 2 right angles, because if you had 2 right angles, that would add up to 180, and I'd still have a 3rd angle, and I'd already be at 180. So you can't have 0 degrees for an angle. So it's only going to have 1, and that's true always. You're never going to have 2. You can't have 2. It's actually impossible. So don't worry about that. If you have a right angle, it's a right triangle. Okay? And then you got your obtuse triangle. And the obtuse triangle only has 1 obtuse angle. In this case here it is, right? It has to be greater than 90 degrees. Now, by the way, these two are going to be less than 90. Same reason for my right triangle. If you think about it, if you added up, or if you had one angle that was greater than 90 degrees, you can't have another angle that's greater than 90, because the three angles must add up to 180. So if you have anything over 90, you can't have anything else over 90, or else you'd already be above 180 degrees. So only one obtuse angle makes an obtuse triangle. Please don't start thinking you need three obtuse angles. That's impossible. So those are your triangle classifications by angles. Again, as you notice, there are 4 of them. And from here, we just go into then classify triangles based off of the angles. And just like with anything else, we want to make sure we're proving the information. You actually providing data to prove that it is obtuse or acute or right, and whatnot. So in this one, we have FHG, triangle FHG. So if you look at your 3 vertices, we have F. You kind of follow my little marker here. We have F, we have H, and we're looking at G over here. Now this one looks like we have one angle that's missing, but look up here. We got this right angle, and that's 30 degrees. So if I wanted to find this guy right here, we would have to go 90 minus 30 degrees, which is 60. Now remember what we said, if all the angles are 60, this guy, triangle FHG, is going to be equiangular. I'll spell it right this time. There we go. Alright, equiangular. Okay? Again, you're just looking at the angle measurements. Now if I did EHF, that would have been obtuse, because that would be 120, because we have our linear pair here. But they don't want that, so I'm going to label what they are asking you for. And then just to kind of go in as we're knocking these out, we have our equilateral triangles. This is one you can do another chart. Okay, just kind of look and see kind of what we're doing. We have 3 of these. So equilateral triangles, that means you have 3 congruent sides. I just want to let you know on this, equilateral triangles are also, I'd say automatically, equiangular. So if you have an equilateral triangle, guess what? Those are all 60 degrees. The sides are the same length, so are the angles. So an equilateral triangle is going to automatically be equiangular. These are all things you're going to be shown. I would just write it down now, so that way I'm just repeating myself when we get to those theorems. Okay, so equilateral triangles, make sure you know those, and make sure you know that, and that has 3 congruent sides, but also know it's equiangular. Isosceles triangle, there's going to be another theorem associated with this, but here's just classification by side lengths. It has at least 2. That's the key. At least 2. It can have 3. Now, by the way, before I kind of go over that, an equilateral triangle, the one we just did, it had at least 2 congruent sides, which means that an equilateral triangle is also isosceles. Okay, it's just an equilateral isosceles. Normally you just call it equilateral just because, but anyway, so any other situation, if you have 2 congruent sides, you have an isosceles triangle. Now here's the other little trick you want to know. See these 2 sides? The angle that forms those sides, which I have one right here, you see how that kind of goes to this side. It's going to be congruent to this angle right here that forms the other congruent side. So these 2 angles are also congruent. They're called base angles. Again, we'll go over that later on pretty soon here, but I just rather be repeating myself when I get to that. So isosceles triangles, again, they're going to have at least 2 congruent sides, and then therefore they're going to have at least 2 congruent angles. The angles that forms the sides are also congruent. Put that in there when you do it. Then scalene. Now scalene just means you have no congruent sides, so all these sides are going to be different lengths. By the way, they're all going to have different angles as well. So that's an angle. This guy right here would be another angle. Notice I'm doing different amounts of arcs because they're different lengths, different measures. So they have I know it's all about side lengths, but I want you to see that relationship between the sides and the angles. The angles are the same length, or the sides, sorry. If the sides are the same length, the angles that form those sides are the same length. But if the sides are different lengths, like I had here with the scalene, the angles are different measures. Okay? Alright. It's kind of a creepy picture here, but, a lot of students, what they like to do, instead of actually proving things to be true or false, what they do is they just look at the picture and they make assumptions. I'm going to probably talk about this in class, but, for example, if I don't tell you a line is straight, you may look at a line. I know this is like a, kind of, you might be able to tell here, but some people may not recognize that that's not a straight line. Or I have a line like this. You can't really tell. It looks like it's straight, but it's not. So if I don't tell you this is a line, it's like you're looking at a triangle or whatnot, there's no guarantee that that's 180 degrees. Okay? If I tell you that's a line, if I say that's a line, then you can say it's 180 degrees. It's the same thing with side lengths. If you're looking at a triangle and you see this triangle and you're like, oh, well, that's obviously isosceles because that has to be congruent. If I didn't tell you that, you don't know that. So that's why I say don't trust your eyes. Maybe this was like, 40 inches and this was like 39 inches. You don't know unless you can prove it. So make sure as you look at these problems, only go off of the data. Don't go off of your eyes. Don't trust your eyes. They lie to you. Okay, if you can prove something to be true, then that's a whole other story. So anyways, we kind of go through these. I'll come back to that whole trust in your eye thing. That's actually a pretty important concept as we move forward. But example 2 here, classify triangle ACD. So now we're just doing the same thing we were doing before, just we have all these other triangles that we can apply as well. So triangle ACD by the side lengths. I'm looking at this triangle right here, ACD. That's the one on the right. Because I have the little tick marks, I know that's 15. So I'm going to look at my 3 sides. I have 3 different sides. If you know your definitions, you know that triangle ACD is scalene. By the way, this is the answer. I'll just kind of put in there. I'll put in there that's also obtuse. We got, we have one, in this case, obtuse angle. You say, wait, you're trusting your eyes. Actually, I'm not. I kind of can see the work here, but here's how you'd be able to prove that. This is actually an equilateral triangle. See those 3 sides? So those are all 60 degrees. So I know that these are 60, and because this is part of this big old triangle, the BD. This would be a straight line, so that'd be 120. So there's my obtuse angle. So it would be also an obtuse triangle. Okay, but at scalene they wanted that answer. So make sure you understand which one they're looking for, because obtuse would be true if I asked you to classify by the angles, but they said by the side lengths. And then here we're going to find the side lengths of the equilateral triangle. Remember, equilateral means that the sides are the same length. So in a situation like this, you have 3 sides. It doesn't matter which 2 you set equal because they're all equal. So you actually get to choose on one like this. I'm going to pick these 2 sides just because I feel like it. So in a situation like this, you're trying to solve the side lengths. Let's solve for y by setting any 2 sides equal. So 3y minus 4 equals 2y plus 3. So here, if I'm going to solve, I'm going to subtract 2y from both sides. So that's going to be y minus 4 equals 3. And then I'll add 4 to both sides. So y equals 7. Now the key on this is that all your sides should be the same length. So if I went ahead and plugged these in, I should get the same answer every time. So this would be 3 times 7, so 21 minus 4, which is 17. Again, see if this is right. I can do it up here. This would be 14 plus 3, 17. And come down here. I have 5 times 7, which is 35, minus 18, which is 17. So you got your side lengths. Okay. And if it's isosceles, you just got to know which 2 sides are congruent. Look at the angles if they gave you those, and you'd be able to figure it out. All right, last one here. So it says each measure is the side length of an equilateral triangle. So and again, equilateral means all the same side lengths. So determine how many 7-inch triangles can be formed from a 100-inch piece of steel. So basically, if you want to try to figure out what this is saying here, we got this big old piece of steel. I want to make that look a little bit better. Maybe I'll just do a line to represent it. We'll do it over here. Alright, so I got a 100-inch piece of steel, 100 inches. And what we're going to do is we're going to break it up. The question is how many times do I break it up? But I'm going to break it up into 7-inch segments. And each time I have 3 7-inch segments, I'm going to be able to take those 3 segments and form an equilateral triangle. That's kind of what's going on. So again, let me erase this so I can move it over on top. So I've got a 100-inch segment here. Obviously that is not to scale, right? And they're saying how many of these can I form how many of these can I pull out and form a right triangle? So when you look at each one of these triangles, let's look at the perimeter. The perimeter is going to be 21 inches. So that's what we're really asking. How many 21-inch segments can I pull out? Because if I don't have the 21 inches, I need 3 sides for a triangle, then I can't form the triangle. So all we're really doing here is we're going to go 100 divided by 21. We're seeing how many times does 21 go into 100. If you look at this, I know 20 goes into 100 5 times, but this isn't 20, it's 21. So it's not going to go 5 times, it should only go 4. And if you don't see that, again, let's go 21 times 4 and check it out. So 4 times 1 is 4. 4 times 2 is 8. So you look at this and say, okay, if I took out 4 sections of 21 inches, I would still have some length left, but if you look, how much do I have left? Well, that'd be 16 inches. That's not enough to form a 7 by 7 by 7 equilateral triangle. So there is going to be some steel left over. It is what it is. So in this case, we're going to have 4 determine how many 7-inch triangles. So each measure the side length of the equilateral triangle, determine how many 7-inch triangles can be formed for the 100-inch piece of steel. So this would be 4 triangles. And again, it depends on this is worded. I was kind of reading that again. It's kind of hard to tell what they mean. They're saying 7-inch triangles. I guess I'll solve it twice based on the wording. I'm not really sure what it's trying to say. Probably could have clarified that a little bit better. So if this is 7 inches is the sides, then that would be my answer. But if 7 inches actually ends up representing the perimeter, so if I did that, you'd go 7/3 for your side lengths, right? That'd be all 7/3, which is a nasty side length. But let's just say that was the answer. So my triangle has a perimeter of 7 inches. So this is another option. Depending on how it's worded, it's kind of worded bad. It doesn't say how many 7-inch triangles. It's saying how many. It should say how many triangles with a side length, and how many equilateral triangles with side length of 7 inches. Or they should say how many equilateral triangles with a perimeter of 7 inches. Obviously, I'd have to clarify that if I was going to assess you on it. But this way I can at least answer it both ways. So let's just say, again, the perimeter here was 7. Same issue, right? We're still going to figure out how many 7s then go into 100. So 7 goes into 10 one time, which is 7. Pull out that, we have 3. Pull down my 0. Then we say 7 goes into 30. Well, 7 doesn't really go into 30, but it does go into 28 4 times. Again, I'm going to have a little bit left over here, which is 2 inches, but that's fine. Okay, like I said before, we had 16 inches left over before. So here we'd have 14 triangles. Again, it depends on how they're trying to word this question. So I don't mind solving it twice. I'll clarify for you if I ask this question for you, or you have it in your homework, or if I ask it on a test, things like that. Okay. All right, so we got a quick little lesson quiz here. In the lesson quiz, again, we're classifying each triangle by its angles and sides. So as you're going through this quiz, make sure you understand what it's asking for. I need you to name it twice. give me both names, one for the angle, one for the sides. So each question will have 2 answers for 1, 2, and 3. Here it says find the side lengths of the triangle. Again, the key here, it's got 2 congruent sides, right? So remember what you do if you have 2 congruent sides. You set up your equation and solve it. I'll let you figure that out, but make sure you do that. I'm trying to give you some hints here so you guys do well in your lesson quizzes. You have no excuse. Okay, do well. And then we have our reflections. Make sure you finish those and take your quiz, and I'll see you guys in class.